Blue Squadron here, and this is the final video in the series for the customized YT-1300 Millennium Falcon. In this video, we're installing all of the electronics into the base of the trophy. I designed this base in Tinkercad to fit directly on top of a large base and then be capped by another large base so that it conforms to the standards necessary for playing on the table. It was 3D printed by local X-Wing player Jonathan Taylor, who is a really stand-up guy, and he did it for free because he just really likes being involved. The components that you see here are going to be an Adafruit PowerBoost 500C, which is both the battery connector and the charger, a LiPo battery, a speaker, and an Adafruit sound effects board with 2-watt 2-channel amplifier. There are openings in the base that allow for various connections. The first one is going to be a slot for a micro USB cable to plug in and charge the battery inside of the case. There's another hole for a power switch, and a third hole for the button that's going to activate the soundboard. Due to the fixed size of this base, I needed to make sure that all the components fit in without interfering with each other. This meant that the battery would probably sit flat, however, the soundboard would have to be mounted onto the side wall of the trophy. I also had to find a way to mount in this tiny speaker to the side of the trophy base. To get an extra power output from the PowerBoost 500, I soldered a terminal block to the USB header. It's also a 5-volt output, which is kind of a standard for USB power. On the sound module, I soldered another terminal block to the left stereo output. I'm only using one channel, so I have to make sure that when I put sound files on the soundboard, that those sound files are mono output doubled to both stereo channels. The Adafruit soundboard also has pins where you can solder in a button. When the button connects one of those pins to ground, it'll play one of the sound effects. I soldered some wires to the back of the speaker and then connected it to the screw terminal. The terminal pins do have a positive and negative polarity shown on the board. However, speakers are really just electromagnets, and they don't necessarily require a polarity. They have a polarity listed on both terminal blocks just to make sure that when you have left and right channels that they aren't what's called phase inverted. This means the sound wave coming from one of the speakers can interfere with the sound wave coming out of the other speaker before you hear it. For a monophonic setup, it doesn't really matter. To power the soundboard, I needed to get a piece of jumper wire that was long enough to reach from the USB terminal blocks all the way to the VIN and ground pins on the soundboard. This simply involves cutting and stripping and then tinning the ends of some pre-made jumper wire. You have to be pretty careful, however, that when you do connect that terminal block, you're connecting the correct polarity. I'm using red for the positive voltage going to the VIN pin, and then whatever that other color is, green or brown, for the negative terminal block to reach the ground pin. My initial attempt to power the soundboard didn't quite work. I tested the voltage of the terminal block pins by using a multimeter. Since it correctly showed that there was a 5-volt connection between the positive and negative terminals, that meant the fault was somewhere else. I ended up also using the Falcon's power connector to see if the PowerBoost 500 was the issue. You'll see me do this frequently, work with live voltage just to make sure that all the components work. Since the Falcon's lights turn on, that means the PowerBoost wasn't the problem. It turns out that those jumper wires that I was using are pretty cheap, and those were the issue. Jiggling some wires on the soundboard later on got it to turn on. The next thing I worked on was the installation of the power switch. I got a new toy to use, which is one of those extension hoses for a Dremel. It's much easier to control than an entire Dremel tool. The hole that I put into the 3D design for the switch was a little bit too small, so I needed to widen it just enough to allow that switch to fit inside of there snugly. The power switch, when closed, bridges the enable and ground pins on board the PowerBoost. Believe it or not, this makes it act more like an off switch rather than an on switch. When the enable switch is grounded on the PowerBoost, it actually disables power output. I took some pre-made female jumper wires, cut them to the correct length, stripped them, tinned the tips, tinned the pins on the power switch, and then soldered it all together with some heat shrink tubing. After connecting it to the PowerBoost, I tested it on the Falcon to see whether or not I could switch the PowerBoost on and off. The square hole for the tactile push button that would activate the soundboard ended up also being a little bit too small, so I had to widen that one as well. I used the same process as the switch for connecting wires to that push button. After hooking up power to the soundboard as well as the push button switch to pins 10 and ground, it was time to test the speaker. The red LED on the soundboard that comes on when I push the button down is the activity light. If it's on, that means I should hear sound coming out of the speaker. I found that the button wasn't that responsive, and the reason was because of these cheap jumper wires. I decided to remove the DuPont housing and solder the DuPont connectors directly to the soundboard. I did the same thing for those faulty power supply jumper wires, and after soldering the female DuPont connectors to the header pins, I insulated each connection with some heat shrink tubing. This made each of the connections stronger, even if it was at the expense of being able to freely connect or disconnect the components. I decided that the speaker I was using was too quiet, so I swapped it out for a much larger one. These 4-ohm 3-watt speakers are a lot louder, and they happen to fit perfectly inside of the base. The next step was to drill mounting holes for this new large speaker. Mark the mounting holes on the inside rather than the outside, only because the speaker was so tall that it came up right to the edge of that lip. I somehow managed to freehand that first hole. The mount holes for the speaker accept 3mm screws. You can find them on Amazon listed as M3 screws, where M stands for metric millimeters. You may see that there's another number. For example, M3 by 12 means that it's a 3mm screw that is 12mm long. That's what you want here. After sinking the first screw, I test fit the speaker and then marked the second hole and drilled it. To hold the speaker in place, I also used M3 lock nuts. They have a little bit of Teflon inside of the threading to prevent the screw from backing out. I also needed a grill for the speaker so that you could actually hear the sound. I freehand marked out a pattern and drilled out a whole bunch of holes for that speaker grill. Hindsight is 2020 once again, and it would have been better to include the speaker grill in the design for the 3D print. Drilling into 3D printed material left a lot of burrs that I had to trim off and then sand. Now it's time to mount all of the components into the trophy base. The power module and the sound effects board have mounting holes that are 2mm in diameter. The hand drill finally paid off. The 3D printed plastic as well as the large base are soft enough for the hand drill to go through. The mounting screws actually come up from beneath the large base, going through both the large base as well as the 3D printed trophy base. I used 2mm screws and 2mm locking hex nuts. One thing that I would have done differently is to use only the mounting holes that are near the micro USB connector at the outside of the trophy base. It's the part of the board that actually receives the most stress from plugging and unplugging the micro USB connector, and there's more clearance for the lock nuts. Also, you may notice that I'm trying to hold the screw in place while using pliers to turn the lock nuts. Both of these mistakes resulted in me damaging one of the components on the board. I knocked one of the surface mount components partially off of its soldering pads. While it didn't seem to affect the functioning of the power boost, I didn't really want to take any chances either. I repaired the component by applying a little bit of solder to each side of the component, reattaching it to the soldering pads. There are products such as solder adhesive paste which can be applied using a needle to repair these types of surface mount components. However, even an ounce of silver electronics adhesive is very expensive. Once everything was working again, I continued to put screws through the other two mounting holes. To mount the soundboard, I decided to use the side wall of the trophy base. Once again, I used the hand drill. I freehanded the first hole but actually missed the first time and had to start again. What made it challenging was that there's actually a chamfered lip inside of the trophy base. This overhang supports a rim that fits nicely inside of the large X-wing base that goes on top of the trophy base. I trimmed off a little bit of the excess metal on the underside of the board from the solder points. Word of the wise, if you don't want those little metal shards flying everywhere, you're going to want to put your thumb over each of those points before you trim off the excess metal. Before mounting the soundboard, I had to add some additional screws to the base. I found that the X-wing large base that I was mounting was a little bit warped. Adding some screws to the four corners allowed it to sit more flush with the 3D printed base. Flattening the base may even make it a little more on-spec than, well, frankly, a fair number of the X-wing large bases that are inside of my collection. With the X-wing base mounted to the 3D printed trophy, now I can add the other components. That's 2mm screws and lock nuts for the soundboard, and 3mm screws and lock nuts for the speaker. This next step involved, well, a lot of drama with glue. I was trying to seat and glue in the power switch and the soundboard button. Unfortunately, the holes weren't the right size, and I ended up getting glue inside of both the switch and the button that I had to clean out. In the future, instead of using surface mount components, what I really should be using are panel mount switches and buttons. Panel mount components, while a little bit larger, are easier to work with. They have an assembly that contains the button or the switch, as well as terminal blades, and a threaded collar which pins the component in place. You simply drill a hole for the button or switch assembly to go through, and then use the collar to hold it in place. There's no gluing involved. The final piece of the puzzle is the top large base. This is the one that actually holds the large base peg for the Falcon to sit on top of. I drilled holes through a large base, cut the power pigtail in two, and then spliced it together on opposite sides of the large base. I used this opportunity to extend the power pigtail a little bit, and then used heat shrink tubing to hold it together. After a final test with the Falcon's electronics, I used some super glue to glue the large base down on top of the trophy. And finally, it all comes together.
There she is, my pride and joy, the Millennium Falcon.
Think. You want to make that move. You made that move, okay. I guess I'll have to destroy that little guy. Somehow I never get bored with winning.
I I'd like to thank all the people that subscribed and watched, and most importantly, a lot of people from my local X-Wing community, including Kaz Perch and Jonathan Taylor. Please subscribe to the Blue Squadron YouTube channel to see further work that I'm doing on other models. Thanks for watching.